in Calc 1, given w equals f of x equals x to the fourth and x equals g of t equals sine of t, to find dw dt, you need the chain rule. So we would get, take w, which is x to the fourth, the derivative of w with respect to x is 4x to the third. Take x, which as a function of t is sine of t, and take its derivative, so dx over dt. The derivative with respect to t is cosine of t. And then applying the chain rule, dw over dt is dw over dx times dx over dt. And we can plug in the pieces. And then finally, we do need to replace the x that appears here with sine of t that appeared there. Yeah, in the final step, the intermediate variable x had to be replaced. The chain rule for functions of multiple variables is just a little more involved, but it's not too bad. The same general idea. So here's the thing, don't overthink the questions that are about to be asked here. Based on this diagram, you see a bunch of little dots and arrows. You should only follow along the direction of an arrow. What are all the ways to get from W to S? So you can go from W to X to S, you can go from W to Y to S, and you can go from W to Z to S. What are all the ways to get from W to T? Well, you can go through X, you can go through Y, but there is no path from W to T that goes through Z. Yeah, you'll notice that there's no arrow from Z to T, while there is an arrow from W to Z. Okay, let's look at function f of x comma y comma z, whose output variable we will call w. 3 input variables x, y, z, output variable w, and f of x comma y comma z equals here equals x squared plus 3y cubed plus x z to the fourth, and we'll find the gradient. So we'll take f, the gradient of w or the gradient of f. W is the output variable name, f is the function name, but we're gonna treat those all essentially the same here, and we just need to find partial derivative with respect to x, with respect to y, with respect to z. I've written this using its two other notations here, using the little subscript notation and the Leibniz notation, and we should have 2x plus z to the fourth, comma 9y to the second, comma 4xz to the third. So we'll use this information later. Okay, so we will use these three partial derivatives that we just computed a little bit later.